Very good morning, my dear friends. A hearty welcome to my channel, Mechanical Engineering Lecture Series, and myself, Dr. M.H. Annaya, Vice Principal at Saptagiri College of Engineering, Bangalore. Friends, if you have not subscribed to my channel till now, please subscribe to my channel, share the information with all your friends. Friends, in today's session, we are going to work out a problem on eccentrically loaded riveted joint, wherein 4 rivets are used to support a load of 50 kilonewton, and these 4 are riveted to a vertical column as shown in the figure. As usual, friends, in a system of rivets, you will have to find out the centroid of the rivet system. For example, friends, in this particular problem, you see this arrangement of rivets is symmetrical about the vertical axis and also about the horizontal axis, and hence the y bar means the distance of the center of gravity from the x axis. If you call this as x axis and this as y axis, this is 100 mm is x bar, y bar is equal to 90 millimeter, that is 180 by 2, and this is 200 by 2. And immediately you get into your mind a term called eccentricity, which is given by the distance between the load axis and the CG. So this is 500 and this gap is 100, and we will say this is equal to 600 millimeter, that is eccentricity is equal to 600 millimeter. Friends, now as per the regular procedure followed, let us calculate the values of the direct load, the secondary load, etc. To start with, the direct load FD, the direct shear load FD, is given by P by I, where P is the total load the rivet system has to sustain, that is equal to 50 kilonewton, 50 into 10 to the power of 3 Newton, and I is the total number of rivets in the system. So this I is equal to 4, 1, 2, 3, 4. There are 4 rivets, so this works out to 12.5 into 10 to the power of 3 Newton. And the load is acting in the downward direction, and this FD equal to 12.5 into 10 to the power of 3 Newton acts at the center of each rivet, rivets 1, 2, 3 and 4, in the direction of P, that is in the downward direction and parallel to P. Hence, I am going to show this FD downward at rivet number 1 and rivet number 2, rivet 3 and rivet number 4. And these are all the values of FD, which have a magnitude equal to 12.5 into 10 to the power of 3 Newton, and they act parallel to P. Since the load is acting downward, FD at each of these rivets acts in the downward direction. Friends, next you will have to find out what is the value of the secondary loads at rivet number 1, 2, 3, 4, etc. So friends, you know very well, this load P, which is acting on this system, produces a clockwise moment of 50 multiplied by this value 600, and the moment produced by all these shear loads, that is at F1, F2, F3 and F4, acting at 1, 2, 3 and 4, etc., should produce a clockwise moment about G, and it should be perpendicular to the line connecting CG and the center of the rivet. So it has to act in a direction perpendicular to that, like this. This is F1, this is F2 acting at rivet number 2. Similarly, F3, which is acting perpendicular to this distance. Finally, this is acting perpendicular here. So we have the values of this secondary loads F1, F2, F3 and F4, each acting normal to the line connecting the center of gravity of the system and the center of the rivet, so as to produce a clockwise moment about the center of gravity similar to that produced by P about CG. Friends, now we will have to find out what are the values of these F1, F2, F3 and F4. Friends, we have the formula given by P into E is equal to F1 by L1 multiplied by L1 square plus L2 square plus L3 square plus L4 square, where these L1, L2, L3, L4 etc. are the distances of the rivets 1, 2, 3 and 4 from CG. In this problem, friends, this is L1 that is equal to L2 equal to L3 equal to L4, because all the 4 rivets in this particular problem are placed at equal distance from CG. So friends, I can just simplify this and say this is equal to F1 by L1 multiplied by 4 times L1 square, that is equal to 4 times F1 L1, because 1 L gets cancelled, 4 times F1 L1, that is equal to P into E, where this P is 50 into 10 to the power of 3 multiplied by eccentricity is from P to the CG 500 plus 100, that is 600, that is equal to 4 times F1, the secondary load unknown, multiplied by this L1 is 134.54. 134.54. You may ask me how to obtain this. Friends, you can see here the L1 is this distance from CG to this one. Friends, you know this distance. This is 100 and this is 90. So this L1 is equal to square root of 100 square plus 90 square under root. So L1 works out to 134.54, and after simplification, friends, you get F1, the secondary load at rivet 1 as 55,745 multiplied by 0.54 Newton. This is the value of the secondary load at rivet number 1. Friends, after calculating the value of F1, you have to also calculate what are the values of F2 acting at rivet 2, F3 at 3 and F4 at 4. Friends, you know the secondary loads are directly proportional to the distance of those rivets from the center of gravity, and in this particular problem, friends, L1 is equal to L2 is equal to L3 is equal to L4, and hence we can say this F1 is equal to F2 is equal to F3 equal to F4. So F1 equal to F2 equal to F3 etc. equal to the same value 55,745.54 Newton. Friends, you have calculated the direct shear load and the secondary load due to bending moment, and now the next step is to calculate among these 4 rivets on which particular rivet or rivets the maximum load acts, or in other words, we are going to evaluate or determine a particular rivet which is critically loaded, that is loaded with heavy load. So friends, for this you will have to consider rivet number 1, rivet number 2, rivet number 3 and rivet number 4. Friends, if you see here, if you take rivet number 1, there is direct load of 12.5 into 10 to the power of 3, secondary load is F1 which is equal to F2 etc. Here friends, the resultant of these two at rivet number 1 is equal to is Fd square plus F1 square plus 2Fd F1 cos theta, which is under root. So friends, I will just write down here at rivet number 1 we will say this FR1 is equal to square root of FT square plus F1 square plus 2 times FD F1 cos theta. What is that theta? Theta, friends, is the angle between the direct load and this angle. So this is more than 90 degrees. So here, friends, FD square is 12.5 into 10 to the power of 3 square plus F1 square is 55,745.54 square plus 2 times FD, 2 times FD is 12.5 into 10 to the power of 3 and the other one is 55,745.54 multiplied by cos theta. Cos of theta is this angle. So I will say theta 1 here. Friends, you are going to get a value of this FR1 and which I am very sure is going to be a value of just this value minus this. So friends, if you just observe rivet number 2 etc., you find that at rivet number 2 you have the direct load acting downward, the secondary load at an angle other is perpendicular to L2 and this value, the angle included between those is called that theta 2, say theta 2, which is same as this theta 2. So friends, here we can say that at rivet number 2 the resultant load will be FR2, which is equal to, that is direct load plus secondary load F2, that is square root of FD square plus F2 square plus 2 times FD F2 into cos theta. So friends, what are these values of this cos theta etc.? So here FR2 is equal to square root of 12.5 into 10 to the power of 3 is the value of the direct load plus secondary load is same as that one, that is 55,745.54 square p square plus 2 times 12.5 into 10 to the power of 3 multiplied by 55,745.54 multiplied by cos theta. What is cos theta, friends? That is cos theta 2 here. I can just call it as cos theta 2. That is the angle between the direct load and secondary load here, and this is same as this. If you want cos theta 2, it is nothing but the opposite side, the adjacent side divided by hypotenuse. Adjacent side is 100 divided by this hypotenuse is L1. So this is going to be 100 divided by the adjacent by hypotenuse is L1. L1 is 134.54. This is 134.54 is the value of cos theta 2 I am substituting. So with this calculation, this works out to 655.72 655.72.11 Newton, 0.11 Newton. Friends, and if you observe this rivet number 1 and 2, the rivet number 2 is heavily loaded or critically loaded, and we are going to find out the value of the diameter of the rod required based on this resultant load at rivet number 2, and hence I am going to equate FR2 resultant load at 2 to pi d square by 4 into tau, the shear resistance of the rivet. So I know this value, this is 655.72.11, that is equal to pi by 4 multiplied by the diameter square into the shear stress is 80 MPa. So friends, I am going to get the value of D, equal to 33 mm after rounding off to the standard size. Friends, I hope you're all satisfied with the presentation I have made, and share this information with all your friends. Subscribe to the channel if you have not done so far. Have a wonderful day, and this is Dr. M. H. Annaya signing off.